Dear students, today we are going to discuss the new topic, pressure. Just take a iron nail. See, all of you can see that iron nail has two ends. One is broadened and that is known as head of the nail, and other is pointed tip. Okay, take a wooden box and take a hammer. Try to push this iron nail of the point which has a pointed end towards this wooden block using the hammer. So it will be easy for you to push that, isn't it? Then take the same nail and place the head near to the wooden box and hammer it. Then you will feel a difficulty in order to enter into this one, isn't it? The reason is, in the first case, even you apply the more force in the same two cases, you can see that iron nail enter the wooden box easily compared to the second case. The reason is that iron nail exerts more pressure on the wooden box than the tip of the iron nail, pointed of the iron nail exerts more pressure than the head of the iron nail. So our topic is pressure. Pressure can be defined as force acting on a unit area of surface. Pressure can be defined as force acting on a unit area of surface. See, so what we can write, pressure equals to perpendicular force acting on an object divided by area of the object. In simple words, suppose this is a box, this is our area, and the force is acting perpendicular. Here we are concerned only about the perpendicular forces. In higher classes, you will consider about the more different types of forces. Here we have to mention only about the perpendicular forces. Perpendicular means the force which is acting along with the 90 degree in the surface. So the force acting on an area, on unit area of surface, is known as pressure. In simple words, if you pinch someone, you are applying force, isn't it? The effect of that force is known as pressure. How much pain you will feel is an example for the pressure exerted by the pinch. Okay, so pinching means you are applying the force on someone. If you are pinching your friend, you are applying the force on someone, your friend, and how much pain he feels, that is known as the pressure. That's biological words, but here we are considered on the physics part. So pressure equal to pressure, and the force acting on a unit area of surface is known as pressure. That's the definition you have to study. And what do you mean by unit area of surface? We study that area. What's the equation to find area of rectangular thing? That is length into breadth. What is the unit of area? Meter square. That is the SI unit of area. The unit area of surface means 1 meter square area. That means pressure means the force acting on a 1 meter square area of surface is known as pressure. Okay, so this is our definition. Pressure is the force acting on a unit area of surface. Now, pressure can be represented by capital P, force can be represented by F, and area can be represented by A. Then what we can write? Pressure P equal to F by A. From this one, we can see that pressure is directly proportional to force. Directly proportional means directly proportional to F. When the force increases, pressure increases. When the force decreases, pressure decreases. So, two factors are there on which the force on the pressure depends. The first one is force. If force increases, pressure increases. If force decreases, pressure decreases. The second factor is area of surface. But here it comes denominator, that is inversely proportional. Pressure is inversely proportional to area of surface. You will study what will be inversely proportional in maths. Now I will explain what will be inversely proportional. See here, since the area comes under the denominator, when area increases, pressure decreases. When area decreases, pressure increases. That's the meaning of inversely proportional. When one quantity increases, other quantity decreases. That's the meaning of inversely proportional. Here, pressure is inversely proportional to area of the surface. That is, when area increases, pressure decreases. When the area decreases, pressure decreases. Now we can move to the unit of pressure. See, we know that this is the equation P equal to F by A. What is the unit of force? That is Newton. Then what is the unit of area? Meter square. Then our unit of pressure is Newton per meter square. That is force. The unit, I just write the unit of force N here by m square. Then Newton per meter square is the unit of pressure. And there is one more unit. The name comes from the scientist called Pascal. Pascal is the another unit of pressure that is represented by capital P, small letter a. So 2 units you have to study. The normal SI unit is Newton per meter square. 1 Newton per meter square is also known as Pascal, that is represented by PA. So we have concluded that part. I will explain one example with the area. Porters carry weight. All of you know what are porters, the people who carry the weights in order to help you to take the luggage from the railway station and airport and bus stations and all. So what they will do, here we have studied that area inversely proportional to pressure. See, if you carry something in your head, our area on which the luggage is placed is very less, isn't it? Then we will get more pressure on our head. It will damage and it will be very difficult to carry all this, carry the weight. So what they will do, the porters will they will make a platform with a towel and place on our head. Then they can increase. Suppose this is a surface of your head. Then if you place the weight which have the 10 kg, then there is only this much area come in contact with the weight. So all these 10 Newton force applied on your head on this much area, then it will give more pain on your head, isn't it? Suppose if you place a towel, make it as a platform, and after that place the weight on that, then this much area, the force acting on this much area, isn't it? Then the pressure will decrease. So it will be easy for you to carry this luggage. It's already given in your textbook. Now we can go to the next topic, pressure exerted by the gases and liquid. Take one glass tube, transparent glass tube, which has open ends here and here. Both ends are open. Tie a small balloon on the bottom side. Then fill some water up to this level. Then you can see that the balloon gets bulge, small bulge, because we did water only in this first case. In the second case, take the same glass tube which has the same size and do the same, like just tie one balloon on the bottom side. Then fill this much water. Then you can see that the bulb getting enlarged like this. So the reason is here the pressure exerted by the water, because the amount of water is less, then the pressure exerted on the balloon is less than the second case. So what we can say, liquids exert pressure on the walls of the container. We know that liquids can be, if you want to take some water, you need a bowl or container, isn't it? You cannot take water, you cannot carry water from other one without any container. So where if you, all the liquid exert pressure on the walls of the container where they are taken. Okay, so that's the next point you have to study. So first we have defined the pressure, then equation and unit, 3 cases. Then after that you have to study that liquid exert pressure on the walls of the container. This is one activity you will textbook. Another activity, take a bottle, transparent plastic bottle, and fill up with this much water, then put some holes from the bottom side to this side, from the up to next side. Then you can see that water comes more forcefully than the water comes more forcefully at the bottom side than the upper side. The reason is all these areas, all this water exert pressure force on this can be the water can be considered as different layers. This layer apply the more force on the second layer, and then bottom the third layer it will feel pressure force more force of the first 2 layers. When it comes to the downside, the bottom layer, this much layers exert force on this layer. Therefore, when the force increases, pressure also increases, isn't it? Therefore, pressure in this case will be, bottom side will be more. Due to that reason, the water flows very strong fastly than the previous cases. Then here, why this much water, only this much water flows from this side, because here this layer has less force, can be applied on the second layer. Then water amount of pressure exerted by the water, these layers will be less, therefore the water comes in slower. Similarly, gases can also exert pressure on the walls of the container. For example, take a balloon, just blow air into that. Then you can see that the balloon gets enlarged. The reason is, when you blow the air is an example for gas. This gas, air, will exert the pressure, will apply force as well as pressure on the walls of the balloon. Here instead of container, we are considering the balloon only. So the walls, the air will exert the force on the balloon. As a result, you can enlarge the balloon. So we have completed these two parts. We can move to the last topic, that is atmospheric pressure. We know that we all are surrounded by air. This envelope of air that surrounds the Earth's surface is known as atmosphere. That you are familiar with the name atmosphere. See, this atmosphere can apply the pressure on all the things around us. The pressure exerted by atmosphere is known as atmospheric pressure. What do you mean by atmospheric pressure? The pressure exerted by atmosphere. Otherwise, the pressure exerted by air is known as atmospheric pressure. See where you can feel the atmospheric pressure. Suppose this is the surface of the Earth. This atmosphere extends up to several kilometers, large kilometers. We can divide the atmospheric these layers into different stratosphere, troposphere, and all. You will study more about that in environmental science. Okay. So the pressure exerted by atmosphere is known as atmospheric pressure. That is the last definition we have to study from this chapter. The pressure exerted by atmosphere or air is known as atmospheric pressure. We can see one example. Take a soft rubber sucker. See, I hope all of you see the rubber sucker. You can see a small part with the inside the sucker. You can see air part, isn't it? Then how will you stick this air sucker into the mirror or plane surface? You will press this button, isn't it? When you press this button, then you can easily stick that sucker into the glass surface, plane surface, isn't it? How actually why this air sucker is stick to the plane surface? The reason is if you press this button, then air inside this sucker will escape from the sucker. And see, at the moment you press this one, air inside the sucker will escape from the sucker and move towards the atmosphere, isn't it? Then what will happen? Whatever the concentration of air inside the sucker, there is no air, and whatever outside there is much concentration of air. Then this atmospheric air will exert a force on the sucker in this direction. Okay, from all the direction the air outside the sucker and from the atmosphere exert the force on the sucker. As a result, this sucker will stick into the mirror or plane surface. So we have concluded this chapter. In the last session, we have studied about the definition of pressure, then the unit of pressure, then 2 points, that are the pressure exerted by liquid as well as the gases. The last one, atmospheric pressure. Thank you.